refocus on the math. Woo! Even though silver is biting me. Arr. Okay, so this week we are going, yay, math time. So I highly recommend having, oh, you are sharp teethers. I highly recommend having a notebook or something to write with and something to write on. It's just helpful. It's nothing too intense, guys. We're going to talk about scientific notation today. There is a decimals test-ish, but it's nothing to worry about. Just so I can see how we're doing with decimals. I think points-wise it's slightly higher than assignments, but nothing much. And then we're going to talk about rational and irrational numbers. Ramen hoodie, yes! Now I want ramen. That's what I'm going to have for breakfast. I mean lunch. Ramen is too good. Oh my gosh. So today we're going to use exponents to represent numbers. We're going to express large and small numbers using scientific notation. Right? I love ramen. Oh my gosh. We're going to use, I repeated that, sorry. Estimate and find square roots. We're going to identify terminating and repeating decimals, and then that leads into rational and irrational numbers. So yeah, since we got to do some vocab, it would be a really good idea to have a notebook. So, and this is what's due this week. You've got 4 assignments to hand in: scientific notation, the decimals quiz, test, whatever you call it. It's not super long, no worries. And then squares and square roots, and rational and irrational numbers. And Jackson, just to tell you, if when you're taking a test or something online, you can use notes. We have a really awesome online calculator that I highly recommend. I am a Desmos fan all the way. I'll put the link in chat. Desmos. Oops.
I don't know where my notepad is right now. Is it okay if I just use my computer notepad?
Absolutely okay. You do what works for you. Okay. Totally. Shrib. Oh, that's cool. Desmos. Oh, Shrib. So this is an online notepad. Let's see. Oh, I accept cookies. Oh, that's cool. This is my note. Is it different, like, for everybody? Oh, it locked. Oh, get your own Shrib. Oh, that's so cool. Okay, you can sign up for it. Oh, it looks like gotta accept the cookies. That's funny. Yeah, that's something yeah, I don't know what I went to there. Probably didn't pick on the right thing, but that's cool. Super cool. Okay. Desmos.com/scientific. That is a really good calculator, Jackson, that I would recommend clicking on downloading. And yeah, it's really, really helpful. Another helpful website that we'll talk about later is Mathway. I don't know if it's mathway.com. Wait. See if that's right, the website. Yeah, there you go. Another really cool calculator. So really helpful stuff as we get into more of the algebra-ness here. So, okay. Yeah, you shouldn't rely on it too much, but it's helpful. It really is. Yeah. It is. My cats see something up there, and I don't know. Huh. They're like looking at the air conditioning thing. Hopefully there's not like a bird or something in there. That would be bad. Okay. So guys, we're going to talk scientific notation. So, first thing is scientific notation. What is it? Like what would you describe it as?
It's to make a number shorter.
Right.
Big number.
Yeah. It's a better way. Oh, look at you. Yeah. Gonna grab my hand and start chewing. Silly boy.
He is not using soft paw.
No, he is not. He is claw paw. That's what he is. Claw paw. But he's so cute.
He
Too
has not
cute.
yet mastered the art of soft paw.
Nope. Princess Peach, though, she has started teaching him the scratching post and all that stuff.
Mm-hmm.
It's too cute. Okay, but you're right, Isaiah. It's a shorter way of representing a number instead of like writing out 0 after 0. So if you see this example here, we have instead of 4,900,000,000, wait, trillion? I'm bad with reading those numbers. Oh my gosh. I might have to go get Kitty. Look at that. Do you guys see how she climbed on the air conditioner?
Oh no.
I don't.
Hey, parkour cat.
Yeah, it's parkour.
I think I'm just. She's the tree climber. She's the crazy girl outside.
You gotta put the TV on and put some birds for cats to watch.
Yeah, I might have to. Wow, that's crazy. I'm not getting her down. She's gonna have to figure it out. I refuse. As she knocks all the pictures off my wall. Yeah, that's what's gonna happen. So yeah, she's actually getting fixed next week, so that'll help. Silver has it on Friday. Sorry, Silver, but that's what happens. Okay. So yeah. Oh my gosh, that would be a big expense. Holy cow. But there are places that do it pretty reasonable. I chose the place in town because they'll keep them overnight, which is what I need. So yeah, so shorter way to represent stuff. So we're going to talk about going back and forth between scientific notation. There's a really good method to do that. But if you look at this, there are 9 place values that we've moved. 3, 6, 7, 8 zeros, but you see how we have a 10 to the 9th here. So it doesn't really refer to the amount of zeros, it refers to places that you're moving that decimal. And we are going to write a process for that, like this. So this is a good screen capture to take, or this is a good, Trey's got a pretty epic hat. Converting. Look at that. Threw my mojo off there. So we're going to convert to scientific notation. Okay? And this is kind of the way, like the process of how to do that. First step is you're going to place the decimal right after the first whole number digit. And that is only if there is no decimal already in the problem. So if no decimal, if there's no decimal already in the problem, okay, good. Yeah, then you're going to put the decimal after the first whole digit number. Second step is you're going to write all the numbers after the first number until you get the 0. Okay, so if you have, oh, she came down. All right, crazy cat. If you have lots of digits, all of the numbers stay in the problem, but the zeros get dropped. Count how many places you moved and write times 10 to a power. So this one here, okay, see this example? Guys, we already had the problem written with a decimal in there, okay? And the whole objective is you want to have one number in front and then a decimal and then however many numbers after. You're only allowed to have one decimal in front, one number in front of that decimal, okay? So we took our decimal point and we moved it until we just had one single digit in front of the decimal. 1, 2, 3. We moved it 3 places. And since we moved to the left, we have a decimal that is positive. Whenever you start with a very big number and you make that number look smaller, you have a positive decimal. Okay, that's important to note. Maybe we can figure out a way to put that, but whatever. What I usually say, if you're moving to the left, you have a positive decimal. Okay? So if you go from right to left, you have a positive decimal. Oh, I love how the cats are choosing to wrestle right next to me. That's awesome. No, I do love that. So it's pretty fun. We're going to practice that today. Okay, so in this example here, here's our steps again, okay? First example, 80,000. I don't have a decimal point in that problem, so where am I going to write the decimal? Where should I stick that decimal? What do you guys think? Yeah, between the 8 and the 0. And you could look at it. That's absolutely right. That's where it's going to end up. And you could look at it as either putting it there right away and then just counting the places, or what you could do, oh kitty cats, is you could put it behind all those zeros, put it at the end of the problem, and then let's move it until it's exactly where Trey said. That's where we want it to end up. So 1, 2, 3, 4. So now we're going to drop all those zeros. And we moved 4 places until it was in the correct position. And we went to the left. We made our bigger number get smaller, so we have a positive exponent. Okay? So you could either just put it in the right spot right away and then count, or you can stick it at the end and then slide it over. Let's do this one. So we have a crazy huge number here. Okay, so I'm going to stick a decimal after that crazy huge number because there is no decimal in the problem. Where do I want that decimal to end up? What do you guys think? Little further, little further. You would think so, Vivi. That's really super close. But where do we want our final result to look like? How many numbers am I allowed to have in front of that decimal when I'm all done moving it into scientific notation? 1. Yeah, you're right. You guys are right. So guys, look at what Trey said. Trey said we're allowed to have one number in front of that decimal. Okay, so we want to end up with it looking like this. We want one number in front. Yep, Sam, that's what we had for the first one. You're totally right. Totally right. So since we want one number in front of that decimal, where is that decimal going to go between what 2 numbers? Yeah, Junior, you're totally right. Very good. 4.3. And Trey, you guys are right. So I want it to end up right behind that 4 because I can only have one number in front of the decimal. So now I'm just going to count how many spaces it takes to get there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I moved 10 spaces until it was right after that 4. Well, I actually moved 10 spaces. There's 7 zeros, but the tiny number talks about how many spaces you move. And then we would write 4.3 and we would still leave all the numbers there. We just drop the zeros. So we leave all the numbers there. Yep, you're right. Leave all the numbers there and then drop the zeros. So your final answer should have just one number in front of the decimal, and then all the numbers are behind the decimal and all the zeros are dropped. And that's our final answer. Yeah, I'm not a fan. I feel like this up here is more confusing than it should be there.
It is breaking my brain.
This part up top?
It's just a little bit.
Yeah,
but it's easier than it looks.
Yeah, it is. And I think it's the stuff up top. Let's see if we can fix that. Let's put it a little bit better. We'll add a slide. We'll delete this one. We don't need that. Okay. So we'll say our steps. What are those crazy kitties doing? I can hear the wrestling. Okay, step 1. We'll say if there is no decimal in the problem already, put a decimal at the end of your number. Does that make sense? Okay. Then we'll say move the decimal so that there is only one number in front of it. And then in parentheses, I'll say to the left of it. And then we'll say count how many spaces you have moved. Then we'll say write all numbers in your final answer and drop the zeros. And then we'll say the total number of spaces you moved is your exponents. Then I'll put in parentheses tiny number. And then last thing, if you moved from right to left, your decimal exponents is positive. There we go. How does that sound, guys? A little better? I feel like the other way was more confusing. Yeah. See, I got the notes from what was presented and stuff last year, but sometimes you got to make amendments for what makes more sense. If anybody prefers the other way, I have that too. Totally fine. So cool. Let's keep practicing with that. Okay, so if you put scientific notation into a calculator, it's going to look like this. Okay, I just wanted to bring that up. because saying 3.1e plus 8, that is the same as 3.1 times 10 to the 8th. Just make note of that in case you can see that in a calculator. Okay, so instead of saying times 10 to the whatever power, they'll just say e. That's saying exponent. E for exponent. Yep, 3.1 times 10 tiny 8. Totally right. I love how you guys are putting that, 10 tiny 8. It's a good way to see it. Okay, so now we're going to go the other way, from scientific notation to the number. Okay? So what that says is what you're going to do is write the digits, look at the exponent, and move the decimal to the right. And that is if exponent is positive. So if your exponent is positive, you're moving to the right. If your exponent is negative, you're moving to the left. So let's look at that 6 times 10 to the 7th. Where is the decimal in that first example? I know, Sam, you're totally right. Where is did I say exponent? I meant decimal. Where is the decimal in that first example here? I have to move the decimal. No, it wouldn't make it negative, Sam. It would make it a decimal. And I'll show you examples with that. Hold your question there. That's a good question. So in this first example, if I'm going back into the number form, where is my decimal in that example? If it was negative, Sam, if you had 4 point, that's a good question. I keep saying that, and it would look like this. If it said times 10 to the negative 3, that means you would move the decimal 1, 2, 3. And your number would be 0.004356. So you actually end up with a really small decimal that way. Look at you grabbing my hand there. Okay, so guys, in this example here, where do you think my decimal is hiding? No coffee for you, kitten. Look at this. He thinks he's going to get my coffee. Where do you think? Where would I start moving? Hi, May. So in this one, you can't see it. There's a decimal already in this problem, but in this one, the decimal would actually be right after the 6. So this is the same as going 6.0 times 10 to the 7. And then this means, since my exponent is positive, I'm going to move 7 spaces in which direction, left or right? Since my exponent is positive. Oh no, you're good. And even if I like all answers, even wrong ones, those are my favorite, because that's where we learn best, right? Yeah. So which way should I move, you guys? Should I move to the left or to the right if my exponent is positive? Kind of says it right here. Righty, righty, you're right. I would go left if my exponent was negative. That's what I would do, because remember, this says a positive 6 and a positive exponent. So we want this number to get bigger. So we're going to move to the right. So we're going to go I'm going to move this here for a second. We're going to go 1, 2, 3, 4, 5, 6, 7. And then every space that I moved, I'm going to add a 0 in there. So then my number here, 6 billion. Right? Oh, 60 billion. Wowza. Wowza, wowza. Million. Million. That's million. My bad. 60 million. Yeah. Yeah. What I mean, and I suppose I should clarify, if you ever see a whole number here, the decimal is always at the end. So if you have like 234, that's like saying 234.0. So it just helps with figuring out where to start moving that decimal. So now this one already has a decimal. So I don't need to do anything. So I'm going to put my pencil on the decimal, and then I'm going to move in which direction? Am I going to go left or am I going to go right? Exactly. I'm going to go to the right because this is positive. And how many spaces am I going to move to the right? 3. Yep, very good. 1, 2, 3. And I'm going to add in a 0. So we have 8,430. And what I would have written down in your notebook, 60 million, 6 millionths. If it would be millionths with the 0 if it was like this. So millionths would make it into a decimal. Yeah. Good questions. All right. No other one there. What would you say for the one under 6? Oh, right here. That is just that is still the 60. Oh, 6 point. That's just 6. Yeah, there's no values after the decimal, so there's no 6. No there's nothing else to say. You would just say 6. Yeah, you can turn any whole number into a decimal like that just by adding the decimal point and a whole bunch of zeros after it, but it's still just a 6. You really only, oh, there's a kitty by me. I love kitties. Kitties are so sweet. You would really only read it as like millionths or something like that if there was a value there. So good questions. Jeez, you guys are awesome. Okay, so what would I do here? Here I want to convert it into a number. So I'm going to put my decimal on that 9.5 on that point there. And I'm going to move in which direction? Left or right? I'm going to go left. Exactly. Because we have a decimal. I know I spent too much time chit-chatting. I tell you. Way too much time. 9:30, 10. Oh, no. That's okay. We're good. No problem. So way too much time chit-chatting there. So we're going to go to the left because we have a negative exponent. And how many spaces am I going to go to the left? Good. I'm going to go 5 spaces. Now let's check that with what Sam says there, okay? 1, 2, 3, 4, 5. So how many zeros am I going to add in front of that 9, 5? Yeah, Sam, good catch, good catch. Sam had one too many zeros. It's super easy to think that this refers to how many zeros, but it doesn't. It talks about, no, that's okay, Sam, no problem. It talks about spaces. So we moved 5 spaces. Now we're going to add in, for every space I moved and there's nothing there, we add in a 0. So there's 0.4 zeros, and then a 9 and a 5. Cool. Very good. Very good. All right. So we're just kind of summing it up here. When the number is greater than 10, the answer is positive. When the number is less than 1, the power is negative. Just think of it this way. If you have a power that's positive, you're going to get a big number. And then if you have a power that's negative, you're going to get a decimal. Okay? So in this example, 7 times 10 to the negative 7th, where am I going to put that decimal to start moving it? Where does it go? Is it before or after that 7? You'd think before, right? But is 7 the same as 0.7? We don't want to change the number. We want to still represent the number the same, but just figure out where that decimal is. Crazy cats, my goodness. They're wrestling. So it would actually be after the 7. So we wouldn't say that this, guys, stop that. We wouldn't say this is the same as 0.7. We would say that it's the same as 7 point. Good, Sam. Yeah, so it starts as 7 point, and then we're going to move that decimal 7 spaces to the left. Okay? Because it's negative, so I'm going to go to the left. We're going to go 1, 2, 3, 4, 5, 6, 7. And then I'm going to add in those zeros. 1, 2, 3, 4, 5, 6. Oh, that's okay. No problem. So we have points, and then there's 6 zeros, and then a 7. Yeah, that's tricky. That's super tricky. Okay, let's turn this one into scientific notation. Let's turn that into scientific notation. So where do we want to move that decimal to? Where do we want that decimal to end up? We want it to end up after the 6, right? So we're going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So what is my exponent going to be? I moved 9 spaces to the right. What is my exponent going to be? Wouldn't be 7, because I didn't move 7 spaces. I moved 9 spaces. Lexi, you totally got it. Sam, good job. Yeah, it would be a negative 9, because I moved 9 spaces. After that. Good. Last one here. Where am I going to go for this one? 9.5. May's kitty is so sweet. I know. Ooh, it's those lickable treats. Those are good. I say it like I've had it. My cats like them, I meant.
They are tasty.
Super tasty, especially the duck ones. So which way would I move there? Yeah, Sam, that looks good. Totally good. Yeah, and Sam's got it for us. Where am I going to move that with that decimal? To the left or to the right for the third one? To the left. Why are you confusion? It's okay to be confusion. Totally. Yeah, I know, right? So Isaiah, I'm wondering if you are confusion because this one here, number 2, you thought it would be 7? Okay, yeah, and the reason it isn't is because what we want to do when we put it into scientific notation is we put your pencil on that decimal, and then you got to move that decimal so it's after your number, because scientific notation always has a number, a decimal, maybe some numbers after, maybe not, and then 10 to the whatever power. So we move that decimal until it's after the 6. And in order to do that, we actually move 9 spaces. And we moved 9 spaces to the right, so that means we have a negative decimal or a negative exponent. So now this one, we have a negative exponent. Negative exponents mean you will have a decimal as your answer. So I'm actually going to move it 5 spaces to the right, to the left. I said the right. To the left, because we want to make it a decimal. 1, 2, 3, 4, 5. So 1, 2, 3, 4 zeros, 9, 5. Very good. Questions on that? I know, it's a little weird. What I would do when you get into Math Excel, look at examples, and yeah, we'll go from there. Now, I'm going to post a video about exponents because we didn't quite get there. I will separate it from this live session just so you don't have to watch the whole live session and all that. But we will pause it there just to not like make brains explode. But I will do that right after I get off recording with you guys, so then I'll put it on Moodle. Okay, so what I would do now after this session, go work on scientific notation and then your decimals quiz thing. And then after that, watch the videos that I post on Moodle about squares and square roots. It'll be very brief, very short. Yes, that is it. You guys are here till 11. I kept you a little bit after. So I apologize for that. But, oh, I appreciate you waiting.